Okay, this will be our second video. This time we're going to use cosine, and we're going to be looking at what happens when we change the value of h. So a is going to stay 1, b is going to stay 1, k is going to stay, it's going to stay 0, and then h is what we are changing. So we're going to use this graph of cosine, changing the value of h. And again, our domain is in degrees, and I'm going by 90 degrees in order to take a look at those quadrantal angles. So here is our graph of cosine. It looks very similar to sine, except instead of starting at 0, it starts at 1. And then I go 1, 0, -1, 0, back up to 1. So a period is counted. It's kind of almost easier to see it with your sine, but it's going to, if I start at 1, it's going to start again when I get back to 1. So you can see I'm still at 360. Now it doesn't matter where I start. If I start at 0, then I could come back here. I've got to be careful. I'm not done because I loop back down. I'm not done there until I get to here, right? So, but that's still 360 degrees. So when I'm taking a look, here it is. This is the one where I restricted my domain. So I'm only looking from 0 to 360. So my cosine starts at 1, and then 0, and then -1, and then 0, and then 1. And that's how it goes. My midline is the same. My range is the same as sine. So my domain, range, period, and amplitude are all the same as sine, except where I'm starting. Instead of starting at 0 and going 1, 0, -1, 0, I'm starting at 1 and going 0, -1, 0, 1. So I'm going to turn most of these off. I'm going to leave those two things on. And we're going to look at x minus 90. Notice the parentheses. That's how you know you're changing h, because it's in parentheses. So h is 90. So yeah, because remember it's x minus h. So h is equal to 90. So this is what that looks like. Now, if you're thinking, golly, that looks familiar, look at my sine of x. They're the same. Sine and cosine are actually just a little shift from each other. We use the same values, we're just shifted over. Shouldn't surprise you, because that's the way that it kind of worked. But let's just compare. So here's my cosine, and then here's my cosine of x minus 90. Notice that what happened, just like we would expect with h, I moved to the right 1. So what was 0, 1 is now 90, 1. I said move to the right 1. I meant move to the right 90. I moved to the right 90. So x minus 90 is going to move me to the right. So 0, 1 became 91. 90, 0 became 180, 0. 180, -1 became 270, -1. And then 270, 0 became 360, 0. And then finally, to finish off the complete cycle, 361 became 451. So I'm just adding 90 to each of the x values. So on this one, when I restricted it to show one complete period, I restricted it 90 to 450. Okay, so just so you can see here, in comparison, I moved that over 90 degrees. Okay, so those horizontal shifts, or the horizontal translations, which we are now going to call a phase shift, they're a little harder to see sometimes. So if you just look at that 0 to 360, the whole thing got moved over 90 degrees. Okay, so let's take a look at what changed when I did that. My midline did not change. And my range did not change. Neither did my domain. Nothing changed except for the graph itself. So all of my domain, my range, the period, the amplitude, all of that stayed the same with that phase shift to the right. So my graph looks different, but none of my key features changed, just the actual points. Okay, so that was a shift to the right 90 degrees. And again, ends up being equal to sine there when I shift to the right 90 degrees. All right, so this one, x minus 180, you would expect this one to shift to the right 180 degrees. So when I take a look here and I turn this on, I'm doing 0, 1. I'm adding 180 to the x. So 180, comma 1. And then 90, 0 becomes 270, 0. And then 180, -1 goes over 180 degrees. 360, -1. So let's again just restrict it to where I'm looking at just that one cycle. This moved over 180 degrees. This moved over 180 degrees. This moved over 180 degrees. Okay? And we'll turn that off. Now, what did that change as far as my key features goes? Well, it didn't change my midline. Didn't change my range. I'm still going -1 to 1. Didn't change my domain. Didn't change the period. Didn't change the amplitude. So I shifted it to the right. Doesn't change any of my key features. It changes my graph, but not my key features. All right, so let's look at what happens if we go to the right 360 degrees. Looks exactly the same, doesn't it? Did I change this? I forgot to change this. So let's say when I go to the right 360, it's going to change that to 360 to 720. So I'm going to start at 360. And if I'm doing my quadrantal angles, I'm going to be adding 90. So 450 and then 540. Hopefully I'm adding these right. I am, because I'm getting 1, 0, -1. The next one should be 0 again. Adding 90 will be 630 and then 520. Nope, 720. I accidentally subtracted. All right, so let's compare again. Let's come up here. And notice that, first of all, they're overlapping. You see that? They're overlapping. Because when I moved, when I moved to the right 360 degrees, darn it, I keep forgetting to click it so it'll not follow with me. When I moved to the right 360 degrees, I moved the whole graph over. That's a complete cycle. So it ends up being the exact same graph. If I move to the left 360 degrees, the same thing will happen. So this became this. Adding 360, adding 360. Okay, so that is why this one ends up looking exactly the same as this one. Because they are exactly the same. They're equal. It's actually one of our identities. Okay, let's take a look at going to the left. So notice this time, that should say cosine, not co-x, of x plus 45. So this time our h is negative. H is -45 because it's x minus h. So notice what this does is it shifts us to the left 45 degrees. So there's cosine. I'm shifting to the left 45 degrees. And again, I think I forgot to restrict this one. Oh, no, I didn't. Okay, there we go. So what was 0, 1 became -45, 1. 90, 0 became 45, 0. So see how I'm subtracting 45 from the x? That's all that's happening there. I'm just subtracting 45. So that shift is just to the left 45 degrees. Because h in this case is negative. Okay, so what does that change? Key features wise? Does not change my midline. Does not change my range. Does not change my domain. Does not change my period. Does not change the amplitude. So everything ends up staying the same key features. The graph has changed, but the key features stay the same. All right, our last one, going 270 again to the left. See how my h is negative here? My h is negative. So I'm going to shift 270 degrees to the left. Notice again, it ends up being exactly cosine because it's a multiple of 90, right? When I move over 90 degrees, it's going to be cosine. It's going to change it to sine rather. All right, so taking a look to this one, and let's do this. Did I restrict my domain? I did not. Oh yeah, I did. Okay, I restricted my domain. So let's turn this off. Let's turn that off. And let's turn this off. So I'm going to the left 270 degrees. To the left 270 degrees. To the left 270 degrees. Okay, so that's all that's happening there. Again, what changes in relation to our parent function? Nothing. Midline stays the same, range stays the same, domain stays the same, the period stays the same, the amplitude stays the same. So nothing changes except the actual point values. And that is it for the H. So again, the H, we now call it a phase shift, but it's a horizontal shift to the left or the right.